Go. Now let's proceed. Theorem 2 states that angles in the same segment of a circle are what? Are equal. What is that trying to explain to us? Now look at this. If I should have probably a shape, let me have a rectangle in this diagram now. If I should split it into two, now can you see this? So I have a segment here, I have a segment. Now it is trying to tell you that angles in the same segment, for whatever you have here, this place here equals to the angle here. If this will confuse you, let me try to clean this off so you can see this clearly. So whatever you have here, if you have A here, this angle must also be equal to what? A. If you have 50 here, this place must also be what? 50. The same way here, whatever you have here, if you have B here, this place equals to what? B also. Can you get that? Just like the S shape you have, the butterfly shape you have. If you have A here, this place must be equals to what? A. So angles in the same segment of a circle, they are what? Equal. If you have A here, this place equals to A. If you have B here, this place equals to B. Now look at this. If I have this here. If I have C here, this place also equals to what? C. Can you see it? Can you see this? Just like turning the diagram upside down. I should probably draw another. Now, of course, the diagram can be like this. Just ensure that they belong to the same segment. That is, look at this, circumference, circumference. The same here, circumference, circumference. So if you have 60 here, this place must also be what? 60 degrees. If you have 30 here, this place must also be what? 30 degrees. So that's what angle in the same segment is actually trying to what? Explain to us. Now let's move to theorem 3. Theorem 3 states that the angle in a semicircle is a what? Right angle. And when they say an angle is a right angle, it means it is equal to what? 90 degrees. So angle in a semicircle is what? 90 degrees. Now look at this. You'll be given a center here. Now look at this center here. Oh, look at the angle facing it here, the opposite angle here. So this place will be equals to what? 90 degrees. I have the angle in a what? In a semicircle. That is half of the what? It actually falls on the what? On the part, or on the half part of the what? Of the circle. Now, this diagram as well, you can draw it upside down. You can have it like this. See your center. Just ensure that the angle facing it is what? 90 degrees. So, theorem 3 states the angle in a semicircle is what? Is a right angle. So that's to tell you that the angle here in a semicircle, this is a semicircle, you have the diagram on a semicircle here, on half of the what? It falls on the half part on the what? Of the circle. Now look at this two in a semicircle. So you have this place to be what? 90, you have this place to be what? 90. While the theorem 2 states that angle in the same segment of a circle are what? Are equal. This circumference, circumference belongs to the what? Same segment. So as explained. Now let's come here. I have 3 questions here for our consumption. Now look at this. Now look at this question. You have been asked to find what? A, B, and C. Now look at A here. I have A here. A belongs to the same segment as what? As 40 degrees. If you can remember the butterfly shape I drew earlier. Now look at this. Let me assist you to a different matter. Look at this. Now, can you now see clearly that A belongs to the same segment as what? As 40 degrees. So you simply say A equals 40 degrees. Reason for that, you tell them angles in the same segment are what? Are equal. and you are done with that. Now, let's move to angle B. Now, you have been asked to find B. B also belongs to the same what? Segment as 40 degrees. Now, look at the shape. Look at that. Look at this. Can you see this? Can you see this? Can you see this? They belong to the same segment. In fact, B also belongs to the same segment as A. Now look at this. Look at this. Look at B. Look at B again. Can you see B? Can you see B and A? Can you see the two connecting? Look at the two. Also, it also belongs to what? This 40. So whichever one you want to use, you are good to go. Let me use B equals to this 40 degree. B equals to 40 degree. You will now give the same reason. Telling them that what? Angles in the same segment are what? Are equal. Now let's move on to C. Now they say you should find C. You just try to locate the same segment that C what? Belongs. Now look at this. Let me bring this out. Look at angle C. Can you see this? Can you look at the C? Look at the C. Look at the C. Look at your C. Look at your C. Can you see that C belongs to the same segment as what? As 32. Can you see that? If I should clean this up, you probably get it better. Can you see that? Can you see that C belongs to the same segment as what? As 32. So you must be able to identify angles that belong to the what? Same segment. You tell them C equals 32, giving the what? Same reason. So that's that on that. Now let's move to question B. Question B says you have to find D and you have to find what? E. Now for me to find D. In fact, this is the simplest one. Now look at this. You have D here. D belongs to the same segment as what? 115. Look at the S shape once again. Let me use a different marker. Look at the S shape once again. Look at the butterfly shape. Look at the butterfly shape. Look at the butterfly shape. The same segment in the sense that what? You have circumference here, you have circumference. It must touch the what? The circumference. It must touch. You must have the vertices, that is the edges touching the what? Touching the circle. So they belong to the what? Same segment. So you tell them D equals to 115. The reason behind that is that what? Angles in the same segment are what? Are equal. I hope you are getting that. Now let's move to find what? E. We have been asked to find E. Now, look at here. E has been structured. You have E here. Now what can you remember? In fact, near seeing this center, you have to remember theorem 3 that states that what? Angle in a semicircle is a what? Right angle. Now look at the diagram falling in a what? In a semicircle, that is half part of the what? Circle. Now look at this. As explained earlier, it is facing what? It is facing E. You can't say this is facing this. You can't say it is facing this. So you have it facing, this is the closest angle now. So you tell them that E equals to what? 90 degrees. And the reason behind that is what? Angle in a semicircle is what? Is 90 degrees. I get it. Or you tell them angle in a semicircle is a what? A right angle. You can do like this. If you don't want to use this, you can use this diagram. It's a right angle. Hope you get that. Or you can actually draw it facing here. It's a what? Right angle. So that's that on that. So this theorem actually proves it combines theorem 2 and theorem 3 together. So you have angles in the same segment are what? Equal, this and this. Then you have what? Angle in a semicircle is what? 90 degrees. Please don't take this for 90 degrees because it must be a triangular shape. Are you getting it? A triangle. Look at it, we are taking this for 90 this is not a what? A triangle. This is quadrilateral, you have 4 sides here. So this is a real triangle. Here you have what? 90 degrees. I hope that is clear. Now, let's move on to what? Question C. Permit me to run this off. So you should write this in your notes. Now, question C says, in the diagram below, we have the diagram here. O is the center of the circle. Thank you. In fact, once you are told that you have the center, you should remember the first theorem and the what? And the third theorem. The first theorem says angle at the center is what? Twice angle at the what? Circumference. So once you are told that you have center, the possible theorems you can remember are the what? The first theorem and the what? The second theorem that says angle in a what? Semicircle is a what? Is a right angle. So let's go, let's continue. BOC is a diameter. Is a diameter. The diameter there, of course, you know, a diameter is a line, is a straight line that divides the circle into 2 equal what? Halves. So that is to tell you that you have a what? A semicircle. Because the diameter will split the circle into 2 equal parts. So you have a what? Semicircle. Now, then I said an angle ABC is what? 37 degrees. A, we have the D here. AD, no, we have the C here. He said angle ADC is what? 37 degrees. You have to calculate what? Angle ACB. ACB. Look at it. ACB. So you have been asked to find the angle here. Now what you do? I told you, once you see the term diameter, you should know that there will be a what? A semicircle in your diagram. Because diameter divides a circle into 2 equal halves. Now, since you have a semicircle, what can you remember? What theorem can you remember? You can easily remember theorem 3 that states that angle in a semicircle is what? 90 degrees. So, looking at this place here will be the what? Here, look at this. Look at the center facing this angle here. This is triangle. This is triangle here. Now look at it. Facing here, you have what? 90 degrees. So you can't just tell them that BCA, or you can say what? BAC. And just ensure that what? The A carrying the angle remains at the what? Center. So you can tell them CAB. Now let's say CAB equals 90. Why is it 90 degrees? You tell them that angle in a semicircle, you can do a semicircle like this. Angle in a semicircle is a what? Right angle. Still the same thing. I'm still saying the same thing. Now, since we know this, don't forget you have been asked to find this. ACB. What again can you see? Look at this butterfly shape. This butterfly shape should remind you of what? Theorem 3 that states that what? Angle in the same segment are what? Are equal. So look at the segment. You have circumference here, you have circumference. So the vertex is touching circumference here. So you have, if this place is 37, this place must also be equal to what? 37 degrees. So you tell them that angle CDA, this place here must be equal to here, and this place is what? CBA, or you can say ABC. You tell them must be equal to what? ABC, which is now equal to what? 37. So they are both to what? 37. This CDA is 37 degrees. It must be equal to this place. The reason behind that is what? Angles in the same segment, are what? Are equal. I hope you are getting that. Angles in the same segment are what? Are equal. Now, we've gotten this place. So, permit me to write there. So, this place is now what? 37. And this place is what? 90 degree. This place is the 90 degree. These are 90 degree. I have been asked to find this angle here. It is very simple. Now let me bring this diagram out. This diagram below. Can you see that? Here you have 90 here. I have 37 here. I have been asked to find this. Let me look at C, B, A. So this, you just apply the principle that you know. The sum of angle in a triangle is what? 180 degrees. So just apply the principle of triangle, then you will get this. You don't need to apply any circle geometry theorem again. So you tell them that angle, when you add these three sides, you must have what? 180. Now you tell them that, let me write, you have to find what? ACB. ACB. So you tell them, when you add ACB, make me to rub this off. When you add ACB to what? When you add ACB to CBA, which is this 37, to CBA, to what again? To BAC or CAB to BAC, you must have what? 180. Why must you have 180? You tell them that what? Sum of angles in a what? In a triangle. So ACB, that is the angle you have been asked to find. So you write it back, ACB plus you have CBA, the CBA to be 37 degrees, then you have the BAC to be 90 degrees, then you finish solving this. So you have your ACB. When you add these two, you have 7, you have 2, you have 180. Then you continue, tell them collect what? Like terms. So they will say, to find this now, you now collect like terms, collect like terms. So you have ACB equals 180 degree minus 127 degree. We're going to bring this one to the other side. So now ACB equals what? D should give us 3, so minus 2, 5.